So, Rohini College of Engineering and Technology from Department of Civil Engineering. So, this is our final year civil engineering subject. So, 7th semester subject. So, our subject title is C8703 Structural Design and Drawing. I'm Michael Devadurai, Assistant Professor. So, today we have seen about the topic is design a hand operated overhead crane. So, example 3, they design a hand operated overhead crane which is provided in a shed whose details are capacity of crane is equal to 50 kilonewton, longitudinal spacing of column is equal to 6 meter, then center to center distance of gantry is 12 meter, then wheel spacing is 3 meter, then edge distance is 1 meter, then weight of crane girder is 40 kilonewton, then weight of trolley car is equal to 10 kilonewton. So see the diagram. So hook is like 60 kilonewton from 1 meter from the reaction A. So solution, step number 1, find wheel load. So to find the support reaction first, okay. So weight of the crane girder is equal to per meter span is equal to 40 by 12. Span is 40 by 12. It's equal to 3.34 kilonewton per meter. This is a UDL load. So weight of the crane and the trolley added together and placed at 1 meter is equal to 50 plus 10 is equal to 60 kilonewton. So see the diagram. Reaction A and B, 2.25 meter on load and 0.75 meter after the load. So there is a 37.5 kilonewton. So RE into 12, because 6 into 12 minus equal to 60 into 11 plus 3.4 into 12 square divided by 2. So RE is equal to 75 kilonewton. Then wheel load is equal to RE by 2. So RE is equal to 75 divided by 2 is equal to 37.5 kilonewton. So step number 2, find the bending moment in Gantry girder. So see the diagram, marking the values from the wheel loads. So RE is equal to 46.88 kilonewton. So RE is equal to 28.12 kilonewton. So maximum bending moment is equal to 28.12 into 2.25 is the distance is equal to load into distance equal to 63.27 kilonewton at the trailing wheel. So add 10% for impact. So already in our previous problems we had taken as the impact load as at 20%, but in this problem taken as a 10%. So because of you can up to 20%, you can take in adding 15% also, you can take 18%, 12%, you can take anything, okay. So M1 is equal to gamma M0 into moment. So gamma M0 is 1.1 into 63.27, so 69.60 kilonewton meter. So maximum bending moment due to self load of the girder and rail taking total load as weight is 1.2 kilonewton per meter. So M2 is equal to WL square by 8 is equal to 1.2 into 6 square by 8. So 5.4 kilonewton meter. So total bending moment M is equal to 75 kilonewton meter. So find maximum shear. See the diagram. So shear force equal to R is equal to 37.5 into 6 meter, then 37.5 into 3 meter divided by 6 the full span length. So 56.25 kilonewton. So step number 4, find lateral loads. So 25% of lateral load by number of wheel loads. So 25% means 0.25 will be 100 into 60 by 2 is equal to 0.75 kilonewton. Then maximum bending moment due to lateral load M is equal to moment. Apply the moment is equal to 1.27 kilonewton meter. Then step number 5, selection of section. So economic depth of section is equal to L by 15. We know the formula. So L by 15. So L is the span length. So 6000 mm divided by 15 is equal to 400 mm. So let us try ISMB 450 or 710.2 Newton per meter. IS code 800 2007. So page number 138. So Flange Criteria, B by TF is equal to 75 divided by 70.4 is equal to 4.31 is the less than 9.4 epsilon. So this section is the plastic section. So web criteria is the d by tw is equal to 415.4 divided by 9.4 is equal to 44.19. So it's less than 83.9 epsilon. So this section is the plastic section. We know the conditions in our code book. Then step number 6, shear capacity. So Fy Vd is equal to Fy into A root of 3 into gamma m0. So 250 into 250 is the Fy given in our question. So A is the area, flange area. So 450 is the flange width and 9.4 is the thickness of flange. So divided by 3 into 1.10. So 5.555043 Newton. So 555 kilonewton. So is equal to 56.25 into 1.55 divided by 555. 0 is equal to 0.152 is less than 0.6. Check for torsional buckling. So Tf divided by Tw is less than 17.4, 9.4 is equal to less than 2 is 1.85. So beta Lt is equal to 1.2 for plastic section. So MCR is equal to elastic critical moment. So MCR is equal to all the values, you can apply that directly. The KL values, KL is equal to 1 point into 6000 is equal to 6000 mm. So MCR is equal to 1.2 into pi square divided by 2 in 10 power 5. So it's equal to 246 into 10 power 6 Newton mm. So lambda LT is one formula. You know all the beta values if you know, Z values if you know, then mu also know, the MCR also known values. So apply all the values, you get the answers immediately. The lambda is equal to 1.248. Then pi LT is equal to 0.5 into 1 plus alpha LT. Then gamma lambda LT minus 0.2 is lambda. We know all the values. Just apply the values, you get the answers 1.389. So XLT is equal to the pi values and lambda values are there. You know that all the values. So all the pi values. So apply the values. 1 divided by 1.389 or pi value is the 1.389. So lambda XLT is equal to 1 divided by 1.99 is equal to 0.5. So FBD is equal to XLT Fy divided by gamma m0. So this formula is from our code book IS 800 2007. So apply all the values, you get the FBD is equal to 113.7 Newton per mm square or megapascal. So MD is equal to beta B into ZP into FBD. So this formula also from our code book IS 800 2007. So apply all the values, you got the answer 174.34 kilonewton meter. So factored longitudinal moment MF is equal to 75 into 75 is our moment load. So multiplied by 1.5. So 1.5 is the factor load constant value. So you got to 112.5 kilonewton meter. So factored lateral moment MF is equal to 1.27 into 1.5 is equal to 1.91 kilonewton meter. Then lateral bending moment capacity MDL is equal to, we know the formula ZPy into Fy divided by 1.10. Then ZPy is equal to 2 into shape factor into Fy, so 1.10. So you know all the values, you can apply just it, you got the answer is 14.53 in 10 power 6 Newton mm. So 14.53 into kilonewton meter. So convert Newton mm to kilonewton meter. Is Newton is replaced by 10 power 3 and mm is replaced by 10 power 3. So 10 power 6 Newton kilonewton meter. For safety, for MF divided by MD, longitudinal plus MF by MD is lateral is less than 1. So this name is difficult, but M by MD, My by MDX. This is our common formula. So less than 1 is equal to hence safe. So we know all the values is less than 1, 0.78. So hence the section is the safe. So hence the section selected is adequate and safe. Thank you.